So hello students, here we are going to welcome you to MockTest4You, which is initiated by Minerva. So myself Mullah Sohail, and I will be taking your mathematics. So with that, we're going to start where we are left off yesterday. So yesterday we are doing inverse trigonometric function, and we started with the definition, domain, range, and different type of inverse, 6 different types of trigonometric functions, and with them the respective inverse trigonometric functions. We discussed the domain and range of them. So today we will be just continuing the topics which we left off yesterday, that properties of inverse trigonometric functions. It will be ITF. Now this one we have done yesterday, that sine inverse 1 by x is equal to cosec inverse x. Now for today's class we're going to start with the second property, that is sine inverse minus x is equal to minus sine inverse x. So this is my second property which I'm going to discuss today. So this is equal to minus sine inverse x. So how is it possible? So first thing, in order to prove this formula, what I will do is, I will write this one, let sine inverse minus x is equal to y. After writing this thing, what I will do, I will take this sine inverse in that side. So I will write minus x is equal to sine y. Now again, I will take this minus that side. So I get x is equal to minus sine y. Now in class 11, we learned one formula, that is sine of minus x is equal to minus sine x. So here we can see that it's minus sine y. So we can write this one as sine of minus y. Now after looking at this one, now again I will take that sign back. So it becomes what? Sine inverse x is equal to minus y. So from here, can I say, therefore, y is equal to minus sine inverse x? And what did we start y with? We started y with sine inverse minus x. And we are getting what? Minus sine inverse x. So this is the property which you must remember. Now, related to the sine, there are two more trigonometric functions which are related to this property of sine. That is tan inverse. So you have tan inverse. Whenever you see tan inverse minus x, you can write that one as minus tan inverse x. And the other one will be cosec inverse x. That is cosec inverse minus x will be minus cosec inverse x. So these two also follow the property of inverse trigonometric function of this sine, tan, cosec. They have the same output, that is minus of sine inverse x, minus of tan inverse x, and minus of cosec inverse x. So this is how we need to remember the formulas. So when you see sine, tan, cosec, you need to remember like this. So all these three follow the same criteria. Now how to remember? Look, it's sine. Just remember this sine. Sine inverse minus x is minus sine inverse x, right? So cosec is what? Cosec is inverse of sine. Now once we know it's inverse of sine, so obviously cosec will follow sine, right? And tan is what? Sine by cos. So basically if I think that in tan, sine is superior to cos, because sine is in the numerator. Look, these are the ways how you should memorize. These are the ways. It's not obviously you have to do like that, but if you remember the sine, tan, cosec formula properties, then it's fine. But if you it's a difficulty to remember, then you can think like that. Okay, now the next one is the cos inverse one. Let us discuss the cos inverse one. So we have another property, that is now the cos inverse minus x, and that is given by pi minus cos inverse x. Now it follows a different rule. Sine inverse minus x was directly we used to write minus sine inverse x, but cos inverse minus x is pi minus cos inverse x. Now from where this pi came out? So let us prove that thing. Let us see. So again we'll do what? Let cos inverse minus x is equal to y. After writing this, I will take cos inverse that side. So we get minus x is equal to cos y. So x is equal to minus cos y. Now again we move back to class 11. In class 11 we knew that cos of minus y is equal to cos y. So we cannot use this formula in here. So what I will do, in place of minus cos y, what can I do? I will write cos of pi minus y. That is minus cos y. Look at here, pi minus y is what? It lies in second quadrant, and in second quadrant cos is negative. So it's coming minus cos y. So in place of minus cos y, I can use this one and I will write x is equal to cos of pi minus y. Now I will take this cos this side. So I get what? Cos inverse x is equal to pi minus y. And from here I can write therefore y is equal to pi minus cos inverse x. So that's how we get this property. That is cos inverse minus x is pi minus cos inverse x. Now just like sine, tan, cosec, they follow the same property among them. Cos also has a gang among himself. In cos gang, who are there? In cos gang there is sec inverse is there. So if you see sec inverse minus x, since he is part of the cos gang, so we will get is pi minus sec inverse x. And there is another one, that is cot. Cot inverse minus x is equal to pi minus cot inverse x. Again you see, how can I remember this property? You just remember the cos one. Cos inverse minus x is pi minus cos inverse x. Now you see sec. Sec is what? Inverse of cos. So once you remember cos property, so obviously the same property will be applied in sec. And in cot, cot is what? Cos by sine. So again you think like that in cot, cos is given more superiority. Cos is more superior than sine. So cot will follow the property of cos. So we are done with these two, that sine inverse minus x and cos inverse minus x. Now let us move on to the next property. The next property is sine inverse minus x plus cos inverse x is equal to pi by 2. Now how did we get this thing? Let us prove this one first. So what I will do is, I will just take sine inverse x. I will write let sine inverse x is equal to y. After writing this, the way we used to do, we'll take the sine inverse that side. So x is equal to sine y. Now we all remember this formula, that sine y, we can transform it into cos by writing cos of pi by 2 minus y. We can write like that. So the same thing I will write here. So x is equal to cos of pi by 2 minus y. I'm going to write like this. Now this cos, I will take this side. So what happens? So I get cos inverse x is equal to pi by 2 minus y. Now look at this expression carefully and you see here there is y. Now what is y? We have assumed y as sine inverse x, right? So put there sine inverse x and you see cos inverse x is equal to pi by 2 minus sine inverse x. So sine inverse x goes that side. So I get sine inverse x plus cos inverse x is equal to pi by 2. So this is another property which we have learned. Now using this property, we will find different trigonometric pairings. Look at here. Sine y was cos 90 minus y. What was sec y is equal to? Sec y was what? Cosec 90 minus y. In the same way, tan y was what? We could have written that one. Cot of 90 minus y. We could have written. So the same thing, since sine and cos forms a pairing, sec and cosec will also form a pairing. So we can write sec inverse x plus cosec inverse x is equal to pi by 2. And the other one is tan inverse x plus cot inverse x is equal to pi by 2. So another pairing is formed. So by this way we have learned the other property of inverse trigonometric functions. So let us move on to another properties. Look, these properties are very easy to remember if you know how to derive these ones. Don't try to memorize. It's best to derive and then learn, because the more you write, the better it is. I'm telling you again and again, in mathematics, the formulas, there are numerous formulas are there, but the best thing to do is you need to write the formulas and make yourself an own formula booklet. Make your own formula booklet. Now let's do this one. Tan inverse x plus tan inverse y is equal to tan inverse x plus y divided by 1 minus xy. So we have this formula. Tan inverse x plus tan inverse y is equal to tan inverse x plus y divided by 1 minus xy. So how to do this formula? So first thing what I will do is, I will write this one tan inverse x as theta and tan inverse y as phi. I'm going to write like that. So what we are getting in here, listen very carefully. In the left hand side, we are getting what? So theta plus phi is equal to tan inverse x is what? X is what? Tan theta. Look at here. Tan inverse x is theta. So x is equal to what? From here, x is equal to tan theta. So we have here tan theta plus tan phi divided by 1 minus tan theta tan phi. Now my whole problem, this I needed to prove this one. Now the proof have changed into this one. Okay. Now which one is looking bigger? This side, right? So let us start with this side. So what do you get here? Tan inverse tan theta plus tan phi divided by 1 minus tan theta tan phi. And whose formula is this one? We can directly see that this is the formula of tan theta plus phi or tan x plus y. We have learned this formula before, that this is the formula of tan theta plus phi. So I can write this one as tan inverse tan of theta plus phi. Again you see tan inverse and tan, they will go away, and what we have? Theta plus phi. And that proves it. And that is what we got the answer. So tan inverse x plus tan inverse y is nothing but tan inverse x plus y divided by 1 minus xy. Now the same thing in class 11, we knew that formula tan inverse x plus y, tan inverse x plus y is equal to tan inverse x plus tan inverse y divided by 1 minus, we are making a mistake, I'm sorry. There will be no inverse in here. Class 11, we haven't learned inverse. So I was talking about this one. Tan x plus y is equal to tan x plus tan y divided by 1 minus tan x tan y. This formula which I was talking about. Now, related to this one, there was another formula. That was what? Tan of x minus y was tan x minus tan y divided by 1 plus tan x tan y. So in the same way, we can say that tan inverse x plus tan inverse y, I can have another property, that is tan inverse x minus tan inverse y, and that will be given by what? Tan inverse, here you see tan x, so I will x minus y divided by 1 plus xy. So these are the two properties in which we have of tan inverse x and y. Now, related to this properties, suppose I say that these x, for the first one, now look at the first case. Suppose y is equal to x. Suppose y is equal to x. So what I can write? I can write this one as 2 tan inverse x. If y is equal to x, so tan inverse x plus tan inverse x gives us 2 tan inverse x. It's a special condition where y is equal to x. And we have tan inverse, this side we have x plus x divided by 1 minus x into x. So the formula of 2 tan inverse x is tan inverse 2x divided by 1 minus x squared. That's the formula of 2 tan inverse x. Now this one is done. Now let's move on to another two different formulas. The last two formulas we have. Let's do this one. 2 tan inverse x is equal to Now 2 tan inverse x is equal to sine inverse 2x divided by 1 plus x squared. Now before going through this problem, let me just recall, go back to the class 11 portion. There we have learned two different formulas, one of sine 2y, sine 2x and cos 2x. And what was the formulas? The formula of sine 2x was 2 tan x divided by 1 plus tan square x. And the formula of cos 2x was 1 minus tan square x divided by 1 plus tan square x. So these two formulas we have learned in class 11, and applying those two, we will derive this formula. So we can see this one, we have to derive this. So how should I start with? What I will write is, let tan inverse x is equal to y. So I'm writing tan inverse x is equal to y. So this implies what? So x is equal to tan y. X is equal to tan y. So I will do, what I will do, I will just look at this one and I will derive. So I have sine inverse, in place of x, I will write tan y, 2 tan y divided by 1 plus tan square y. And we can very well see that 2 tan y divided by 1 plus tan square y is the formula of sine 2y. That is sine inverse sine 2y. So sine inverse and sine goes away. We have 2y. And what was our y? Our y was tan inverse x. So I get 2 tan inverse x. So that's how we derive the formula like this. In the same way, for the cos inverse one, that was 2 tan inverse x is equal to cos inverse 1 minus x squared divided by 1 plus x squared. We will take the same assumption that let tan inverse x is equal to y, and you will be doing that. Okay, so from up till today we have learned so many different properties of inverse trigonometric functions. So now we'll be starting to learn the problems, because until and unless we solve problems, we cannot remember these properties. So let us start by solving different problems. So the first problem of the day is this one. What do we see in here? We have to prove that 3 sine inverse x is equal to sine inverse 3x minus 4x cubed. So from the very childhood we learn that whenever you have to prove something, always take the complicated side and try to simplify that thing. So I will take this side and I will write sine inverse 3x minus 4x cubed, and I will try to simplify this one. Now when I look into this formula, just inside thing, forget this inverse, sine inverse thing. When I look at what is inside 3x minus 4x cubed, what I will do is I will roll back ourselves to class 11. Again we are doing that. We have to do continuously. In class 12 we have to go back to class 11 again and again. Why? Because we have to pick some formulas which we have learned in class 11. So by looking at this one, you see, I hope you can see this one, 3 sine x minus 4 sine cube x. If you replace this x with sine x, you can look at this one, and this one was the formula of sine 3x. So let us utilize this formula and try to solve this one. So if I start doing it, so what I will do is, I can write let x is equal to sine theta. Let x is equal to sine theta. Because I can use this formula only when we have sine x in there. But here we have only x. So what I do, I transform the x into sine theta. So let us see what we get. So if I do that, so my sine inverse, what is inside the sine inverse? It becomes 3 sine theta minus 4 sine cube theta. Now you see, this is the formula of sine 3 theta. So let us write there. So sine inverse sine 3 theta. And now sine inverse and sine will go away. We have 3 theta in here. And what is theta? X is equal to sine theta implies that theta is equal to sine inverse x. So it is 3 sine inverse x. That's my answer. So that's how we try to prove this inverse trigonometric function questions. So now we have another proof in our hand, that is tan inverse 2 by 11 plus tan inverse 7 by 24 is equal to tan inverse half. So let us prove this one. So again you see, in here obviously this one is a bigger side. So let us pick this one and start with this left hand side. So what do you get? If I write left hand side, we are doing solution. So left hand side, so I write that one as tan inverse 2 by 11 plus tan inverse 7 by 24. Now when I write this one, the thing which comes in my head is a property which we have learned in today's class, that is tan inverse x plus tan inverse y, that is equal to, it's equal to tan inverse x plus y divided by 1 minus xy. This is the formula this is the property which we have learned today. So we are going to apply that property in here, because we can see tan inverse x plus tan inverse y form. So if I apply that, what do we get? Tan inverse 2 by 11 plus 7 by 24 divided by 1 minus 2 by 11 into 7 by 24. So this cut. Now let us simplify this one. There is no point in cutting that thing, because if you cut that one, it will complicate that thing. Why? I will just tell you. So after getting this, I will do the LCM in up and down. See what you get. So tan inverse, so I will get in here, that is 48 plus 77 divided by, we are getting in here 24 into 11 divided by 24 into 11 minus 14. So what do you get in here? In the top you get tan inverse, this one is 48 as a divided by 24 into 11. So you see this one gets cut. That's the reason I didn't cut 2 in there. Okay. So I cut those two. So 48 plus 77 is 125. And the denominator which we get is, that is equal to 24 into 11 is 264 minus 14. That gives us our 250. So I get tan inverse 125 divided by 250. So here we get tan inverse half. So that's my proof. So that's how we solve this type of questions. So now we have another problem, that is sine inverse half is plus 2 cot inverse 1 by root 3 is equal to 5 by 6 pi. Again, this is another proof. Another proof question. So basically this chapter, most of the questions comes from, you have to prove the left hand side and right hand side. So again, we'll start with the left hand side, because in the right hand side there is nothing in there. So when I see this problem, sine inverse half. So when is the value, for what angle sine is half? We know that is pi by 6, that is 30 degree. So pi by 6, so we can directly write that answer. Then plus 2 cot inverse 1 by root 3. So cot inverse 1 by root 3, what is the value? Cot inverse 1, not cos, it's cot inverse 1 by root 3. That is equal to what? Pi by 3. It's not pi by 3. Cot, look at here, cot inverse 1 by root 3 is equal to tan inverse root 3 is cot inverse. That is equal to what? Tan inverse root 3. And tan inverse root 3 is what? 60 degree, and that is pi by 3. So I will write here into pi by 3. So how much is that? Let us do the LCM. So if I do the LCM, we get 6 in here, pi plus 4 pi. So we are getting 5 pi by 6. I know it's a very, very easy problem, but we have to do it. So now let's do this one. So what do we have in here? 2 tan inverse 1 by 5 plus tan inverse 1 by 4. You have to prove tan inverse 32 by 43. So now if I look at left hand side, we cannot apply in here tan inverse x plus tan inverse y. Why? Because here we have tan inverse, 2 tan inverse x in there. So when we see 2 tan inverse x, obviously the formula comes out, 2 tan inverse x, the formula is what? It is 2 tan inverse x, the formula is tan inverse 2x divided by 1 minus x squared. Don't muggle up with the formulas. You have to remember which formula we have to apply where. So 2 tan inverse x, the formula was this one. Even I was doing that thing. So that was the formula. So I will apply in here tan inverse, so 2x. So here x is 1 by 5. So 2 into 1 by 5 divided by 1 minus x square they said. So it will be 1 minus 1 by 5 whole square. And let's leave this one like this. Tan inverse 1 by 4. Let us solve. First we simplify this one. Then we'll get to deal with that one. So tan inverse, this one is coming out to be 2 by 5. And this one is coming out to be 1 minus 1 by 25. Plus tan inverse 1 by 4. So this is what we have. Now after this, what I will do LCM in here. So what I get, tan inverse, if I do the LCM, 2 by 5, the denominator we get 24 by 25. We get this thing. Let us cut this one. So let us cut what we can cut. So 2 and this 12, that becomes 12. And this 5 and this 5, it is 5. So 5 will go up. So it becomes tan inverse 5 by 12 plus tan inverse 1 by 4. And now you can see that formula, tan inverse x plus tan inverse y. So we can apply that formula. I can write this one as tan inverse x plus y 5 by 12 plus 1 by 4 divided by 1 minus 5 by 12 into 1 by 4, and that is equal to tan inverse. Now let us do the LCM in the top. So the LCM is what? 12. So 12 here we are getting 5 and plus 3 divided by, we are getting in here 48 minus 5 divided by 48. So let us cut. So here this one gets cut. So 4 will move up. So how much you getting? 5 plus 3 is 8, and that is 32 in the top, in the numerator. The numerator we are getting 32, and in the denominator we are getting 48 minus 5, that is 43. So that's my answer. And you see, that's what we have to prove. And so left hand side is equal to right hand side. Okay, let's move on to the next question. So now we are going to prove this one. Now this problem kind of like looks too big. Now here we have inverse are also in there, and tan and cos functions are also in there. So let us start with the left hand side and see what we get. So when we thoroughly look into this problem, what we see in here, we see 1 minus cos theta and 1 plus cos theta. Now looking at this one, we can remember the formulas in class 11 which you have learned is cos 2 theta had 3 formulas. That was, the first one was cos square theta minus sin square theta. The other one was 2 cos square theta minus 1. Then 1 minus 2 sin square theta. So these are the 3 formulas which you have learned in class 11. And using these 2, I will try to write 1 minus cos theta and 1 plus cos theta formulas. So if I look at carefully, from this here, we are getting 2 cos square theta is equal to 1 plus cos 2 theta. And from here we are getting 2 sin square theta is equal to 1 minus cos 2 theta. So you see here 1 minus cos theta in there and 1 plus cos theta in there. But we are talking about 2 theta. So when the angle is 2 theta, here we can see theta. 2 theta, theta. So when the angle is theta in here, so the angle in here will be theta by 2. Basically, it's a half of the angle which we see in here. So in place of 1 minus cos theta, what I will write? It will become 2 sin square theta by 2. And in place of 1 plus cos theta, I will write 2 cos square theta by 2. So this is what we can write, plus tan theta. Please don't forget the tan theta. So after writing this thing, now to simple, now 2 gets cancelled. So what we have, tan of 2 cot inverse. Now sin theta by 2, cos theta by 2. That gives us tan square theta by 2. And tan square and square root will go away. We have tan theta by 2 in here. So plus tan theta. Now cot inverse, now here you see, here it's cot inverse and here it's tan. So what I will do in here, now look at here carefully. So what I will write is tan of, I need to change this one, I need to make it cot. So how can I make it cot? So I will write 2 cot inverse, I will write here cot pi by 2 minus theta by 2. Obviously I can write tan as cot pi by 2 minus theta by 2. So plus tan theta. Now you can have cot inverse and cot goes away. So what we get? So tan of 2 into pi by 2 minus theta by 2 plus tan theta. Now let us multiply in here. So 2 and 2, that becomes pi and this becomes theta. So this becomes actually tan of pi minus theta plus tan theta. Now what is tan of pi minus theta? Now my whole problem gets reduced to finding the value of tan pi minus theta. Now listen very carefully. Pi minus theta means it lies in second quadrant, and in second quadrant tan is negative. So what I get? Here I get minus tan theta plus tan theta. So these two gets cancelled. We get the answer to be 0. So we have proved the given problem which we had in our hand. Okay, so that's how we have to prove this one. We need to see where we have to apply different formulas. So in inverse trigonometric functions, you have to remember all the formulas which you have learned in the chapter of trigonometric functions in class 11. So like here, so when we are dealing with this question, all we had to do is we need to write this formula of 1 minus cos theta and 1 plus cos theta. And once we have done that formula, all the steps were clear to us. So again, we have to prove this one. So we're going to start with the left hand side. So what do we see in here? Cos, sine inverse, cot, cosec inverse. There are so many different functions that are in here. And there is one small x. So what I need to do, we need to prove this one is equal to this thing. So basically we need to remove the trigonometric functions. And we know how to remove. We know whenever we have sine inverse, we need to get sine. Whenever we have cot, we need to get cot inverse. But here we see cot and here we see cosec inverse. So we cannot remove these two. So what I will do, I have to transform this cosec inverse as cot inverse. Then only this cot and cot inverse will go away. So let us see what I will do this one. So what I will do, I will write let cosec inverse x is equal to y. I'm going to write that thing. So from here we can say that x is equal to cosec y. Now we know we have learned trigonometric identities. In there we know that 1 plus cot square y is equal to cosec square y. Or we can say cot y is equal to square root of cosec square y minus 1. This is the thing which we have learned in, again, class 11. Actually, trigonometric identity, this one we have done in class 10. We have came across this formula. So if x is equal to cosec y, so cot y is equal to what? So cot y is equal to root over of x squared minus 1. So from here, we can say that y is equal to cot inverse root over of x squared minus 1. So in place of cosec inverse x, I can write cot inverse root over of x square minus 1. So let us write that thing. So we have cos, sine inverse, cot inverse root over of x square minus 1. So like this way, after doing this, now you see cot and cot inverse will go away. So what we have? Cos, sine inverse root over of x square minus 1. So now the problem becomes what? Now we have to remove this sine. So how can I remove this sine? So we need to transform it into cos, then only it can get removed. So sine inverse we have to transform into cos inverse. Then we can remove this cos and cos inverse. So let us see how will I do it. So the same way we'll do. So what I will do is, I will write let sine inverse root over of x square minus 1 is equal to y. So root over of x square minus 1 is equal to sine y. This is what we have. Now cos y, from here we know that the formula that cos x is equal to root over of 1 minus sine square x. This is the formula we know, right? So in here, if I have to find cos y, what is that equal to? Cos y is equal to root over of 1 minus sine square y. And the value of sine square y is this one. So I will write here root over of 1 minus root over of x square minus 1 whole square. So square and square root will go away. So I will write root over of 1 minus x square minus 1. Actually minus minus will get plus. So it get root over of 2 minus x square. So I can write y is equal to, so from here I can write y is equal to cos inverse root over of 2 minus x square. So in place of sine inverse root over of x square minus 1, I can write cos inverse root over of 2 minus x square. So what do I get? Cos of cos inverse root over of 2 minus x square. So cos inverse and cos will go away. So we get root over of 2 minus x square. So that's how we prove this question. Okay. So I think this is the way we solve these problems. So now here we have a different type of problem. So what is the problem? So in here we have to write the simplest form of this inverse trigonometric function. So what we have in here is tan inverse cos x minus sin x divided by cos x plus tan x. Sorry, there is a mistake. It will be cos x plus sin x. So here we need to simplify this one. Now once we see that here is tan inverse, in order to simplify this one, so basically we need to remove this inverse and we need to remove this inverse trigonometric function. So tan inverse, obviously how can I remove? So obviously what we see in inside, it has to be tan, then only we can remove that inverse trigonometric function. So let us keep this tan inverse like this, and in here let us introduce some tan, because from small tan we can get the bigger tan. So in order to introduce tan, what I will do is I will divide numerator and denominator by cos x. So if I do this thing, so what we have, why we are doing that? Because we know that sin x by cos x is tan x. So that's the reason of dividing the numerator and denominator by cos x. So after dividing this, now if I separate cos x by cos x minus sin x by cos x, so I can write 1 minus tan x. In the numerator, I can write 1 minus tan x. In the same way, in the denominator, I can write 1 plus tan x. Now, after getting this thing, now we have to visualize this in a particular way. When I look at this question, a formula comes in my mind, that is tan x minus y is equal to tan x minus tan y divided by 1 plus tan x tan y. Now this thing kind of like looks like that one. Now basically 1, for what angle tan is 1? We can write 1 as tan pi by 4. So I can write this one as tan pi by 4. So basically we have x, that is pi by 4, minus tan x divided by 1 plus, now tan pi by 4 is 1. So in place of, in here I can write tan pi by 4 into tan x. So basically it is tan x tan y, because it's 1. So 1 into tan x is just tan x only. So I'm just introducing and writing it to be tan pi by 4 to make it same as this formula. And once we see this one is same as this formula, so we can write what? Tan pi by 4 minus x. So this becomes what? Tan inverse tan of pi by 4 minus x. So now what we see, that tan inverse and tan goes away, and what we have, pi by 4 minus x. So that's how we get the simplest form of this inverse trigonometric function. So all we had to do was to remove that inverse trigonometric function by introducing tan inside that tan inverse function. So thank you students for today's class, and if you have any doubts, any sort of problems regarding the class we have discussed today, with your queries, please try to mail us on our given email ID which you will see in the screen. And so thank you for today.